Radiology, Lecture 1 Fundamentals of Radiology. Radiology is the science that deals with diagnostic, therapeutic, and research's application of high energy radiation. Dental radiograph is a process of production photographic image for an object through the use of X radiation. Dental radiograph help the dentist to examine the internal tissues like roots of teeth and alveolar bone, which cannot be seen by naked eye due to overlying soft tissues. X-ray was discovered by Roentgen in 1895. It travels in form of pure energy, and the basic unit is X-ray photon or quantum. X-ray photons travel with a wave motion called sound wave, and the distance between the crest of this wave called wavelength, and the amount of energy contained in each photon called photon energy, which depends on wavelength and frequency of X-ray. That means the high frequency of X-ray, the shorter wavelength photon. This shorter wavelength photon has more energy than low frequency, long wavelength type of X-ray photon. Inverse proportion. This electromagnetic radiation spectrum showed in this figure. Similarities between X-ray and light. Both belong to the same electromagnetic radiation family. Both travel in straight line at the same speed, which is about 186,000 miles per second. Both affected the photographic films and made them black. Both not affected by magnetic field. X-ray and light cast the shadow of the object in the same manner. Differences between X-ray and light. X-ray has the ability to penetrate object, while the light cannot pass through. X-ray has the ability to ionize atom. X-ray has the ability to produce light, blue light, when it hits some object, and this phenomenon called fluorescence. X-ray is invisible. Component of X-ray machine. In order to produce X-ray, we need X-ray machine. There are different types of X-ray machine. Some of them uses for dental use, other uses for medical, and other for engineering. Our X-ray machine is a dental X-ray machine. Is used to generate X-ray. This machine composed of set-up transformer that consists of two coils of electrical wire, and it used to increase the incoming voltage from 240 volts to 60 kilovolt or more. Step-down transformer, it used to decrease the incoming voltage to around 10 volts in order to supply the filament circuit of X-ray tube with low voltage. Auto transformer. This is made from one coil to do the work of two coils. It can be used to making minor changes in the voltage. Rheostat is a device that used to increase the resistance to the passage of electrical current through the wire. It reduces the amount of electrical current used in X-ray machine through the circuit to about 10 to 15 milliampere. Timer. It causes activation of high tension current across the tube, and this happened when the timer button is pressed. Ammeter and voltmeter. These two components are the same type of instrument since both are operated by magnetic field. This diagram shows the component of X-ray machine. X-ray tube. This the very important component in the X-ray machine. The X-ray tube consists of external and internal structure. External structure including the supportive structure, the protective housing and the glass enclosure, while the internal structure are the anode and cathode. X-ray tube should be vacuum tube so that the electrons are free to travel inside the tube without interaction with air molecule. The glass of the tube is leaded to prevent the generated X-ray from escaping in all directions, while the window of unleaded glass so that the X-ray can exit out through the window. X-ray tube consists of two ends, negative electrode, cathode, and positive electrode, anode. Cathode consists of focusing cup made of molybdenum in which the tungsten filament is set. This filament is the source of electrons that are used to generate X-ray. Anode end consists of thin tungsten bottom set in a rod of copper. This rod surrounded by an oil bath which used to absorb heat that created during generation of X-ray. This figure shows the X-ray tube. This picture shows the X-ray tube, the cathode, and the anode. Generation of X-ray. X-ray photon generated at the surface and within the tungsten bottom target of the anode by bombardment of anode with electrons coming from the cathode when the filament is heated electrically. The speed of these electrons depend on the potential differences, kilovolt, between cathode and anode of the tube. Electrons impacted on the rectangular area at the surface of tungsten bottom to the anode called focal spot. The kinetic energy of these electrons will convert it to X radiation and heat. In fact, there is only 0.2% of this energy will convert to X-ray, while the remaining energy goes in form of heat. This heat will be dissipated with aid of radiator that attach to the anode. This diagram shows the generation of X-ray. Selection of target material. Ideal target material must possess the following qualities. It should have high thermal conductivity, high atomic number, high melting point, and low vapor pressure. Tungsten with copper rod is ideal because copper has high thermal conductivity. Focal spot. It is a small area on the tungsten surface on which electrons come from cathode are impacted and the X-ray photon are produced. Therefore, the useful X-ray beam emerge from this spot. The rectangular focal spot called actual focal spot, while the projection of this spot when viewed from any point with the X-ray beam appear more or less like square. This square projection called effective focal spot. In diagnostic radiography, the use of rectangular focal spot, which is projected as a square, this will obtained by setting the surface of the target at an appropriate angle about 15 to 20 degrees to the cathode. This principle helped to get this benefit. Number one, X-ray generated over large surface area and larger actual focal spot for better dissipation of heat. This is the actual focal spot, and this is regarded as effective focal spot. Types of radiation. Central ray is the X-ray photon that is traveling in very center of the cone of radiation, and it's commonly used to fix and locate the position of X-ray beam. Characteristic radiation. Radiation produced when the outer shell electron fills an inner shell void, empty orbital. Primary radiation. Radiation emerging from the X-ray machine in form of collimated useful X-ray beam. Secondary radiation. Radiation results from interaction of a primary beam with matter. Leakage radiation. The X-ray that escape through the protective housing and result in unnecessary exposure of the patient and radiologic technologist and have no value in diagnostic radiology. X-ray interaction with matter. This is very important. X-ray absorbed by any form of matter, solid, liquid, and gas. When the photons reach an atom, different types of interaction may occur depends on photon energy. Number one, X-ray photon can pass through the atom without any change occur to both of them. Number two, coherent scattering, sometimes called classical scattering. This interaction occurs when low energy X-ray photon. There is no loss of photon energy, only changes in direction, photon of scattered radiation. This is the X-ray photon that hit the atom and cause change in direction. Compton effect. When the X-ray photon has moderate energy, it results in ionization of the atom, ejection of Compton recoil electron, reduction of photon energy. There is some absorption of photon energy by ejected electron, which undergo further ionization interaction with the tissue and changes in the X-ray direction. Scattered radiation. هذه الأتوم هنا يجي الإكس راي فوتون تكون الطاقة مالته مودريت، راح يضرب إلكترون من الأتوم يسوي إيجكتد إلكترون، يفقد جزء من طاقته الفوتون، يفقد جزء من طاقته ويصير بيه سكاترينج. Photoelectrical effect occur by X-ray photon interaction with inner shell. هذه معناتها طاقة الفوتون عالية بحيث يضرب inner shell electron of the atom from K shell The X-ray photon disappears and deposits all its energy. This process is pure absorption. Now, the inertial electron is ejected and considered as a photoelectron because it behaves like X-ray photon into the tissue for further interaction with other electron of the other tissue atom. So, this high energy ejected photoelectron behave like the original X-ray photon, interact and eject other electron as it passes through the tissue. These ejected electrons are responsible for the majority of ionization interaction within the tissue and the possible resulting damage attributed to the X-ray. As we see here, هذا الإكس-راي إجا ضرب إلكترون بالكيشل، فقد كل طاقته. الإلكترون امتص كل طاقة الإكس-راي فوتون وانطلق كفوتو إلكترون. تصرفه بهالحالة راح يكون أشبه بالأوريجينال فوتون. ترك مكانه فارغ، بقت الذرة غير مستقرة. راح ينزل إلكترون من ال شل ويترس مكانه. خلال هذه العملية أيضا راح ينبعث إشعاع. When K electron removed out of the orbital, an electron from L shell fall into K shell and release energy in a form of X-ray photon. This photon has definite wavelengths, so the particular element, this phenomenon is called identify element, and the radiation is called characteristic radiation. There are two other types of interaction pair production between high energy X-ray and the nuclear force field. The photo disintegration between high energy photon and the nucleus, but both of them not occur in diagnostic radiograph. هذا فقط بالإشعاعات العالية يصير. Definition of term used in X-ray: scattering, تشتت, change in the direction of photon with or without a loss of energy. Absorption, امتصاص, deposition of energy, removal of the energy from the beam. Attenuation, reduction in the intensity of X-ray beam because caused by absorption and scattering. يعني الاتنيويشن هو حصيلة الامتصاص والتشتت. Ionization, removal of an electron from a neutral atom. Filtration, X-ray use in dentistry must be able to penetrate dental hard tissue, teeth and bone. The longer wavelength X-ray, soft X-ray سميناها, not useful in diagnostic radiograph. Passing the beam through the filter made from aluminium, which absorb most of long wavelength اللي هي soft X-ray. The resulting X-ray beam will consist mainly of X-ray photon with short wavelength, high energy, and high penetrating power. Collimation, process used to control the size and shape of X-ray beam. In diagnostic radiograph, it's essential to get the diameter of circular X-ray beam at patient skin surface is not greater than 2.75 inch, while the rectangular X-ray beam, the dimensions at the skin should be approximately 1.5 by 2 inches. Thank you for listening.